Hello, sir. Good evening.
Good evening. Sorry for the delay. I hope everything is good. Krishna,
Yes, sir.
Ronaldo. All right. Any doubts from the last classes? Kulsum?
No, sir, no doubts.
No doubts. Shekhani, what about you?
No, sir, no doubts.
No doubts. All right. Today my voice is clear, I hope.
Yes, sir.
All
Yes,
right.
sir, very clear.
All right. I'm back in Delhi. So I hope everything goes absolutely fine. All right. Let's start. Few questions are left of this chapter. Few, not even few, just 2 questions. All right. After that, we'll start relations and functions. All right. Let's start the first question. Find the matrix A. This is very easy question. You can solve this by on your own. Find the matrix A such that determinant A is equals to 2 and adjoint of A is equals to 2, 2, 0, 2, 5, 1, 0, 1. And have you guys completed the assignments, all the assignments that was provided to you?
Yes, sir.
And Shekani? Shekani, have you completed the assignments?
Yes, sir.
No, why not?
I mean, sir, because I do not have access to the program.
Shekani, your voice is very low.
Sir, I do not have access to the program.
I'm not able to understand you. Can you please chat?
Sir, I do not have access to the portal.
Still not audible, Shekani. You can try rejoining or keep the mic closer to you. All right, let me talk to Ronaldo. Have you completed the assignments?
So the starting one I completed, but the rest I couldn't get time to. I'll complete it and upload it soon. So.
Okay, by when will you complete it?
So by this Friday or Saturday.
By this Friday or Saturday. All right. Kulsum, what about you?
Are you talking about the 5th assignment?
All right. So
Yes,
whatever
sir,
that
I've
was.
completed the 5th assignment.
Right. All right. Okay, then try this question. And Ronaldo and Shekani, I believe you have till Friday. All right. I'll give you till Friday to complete all the assignments. You do not have access to the portal. All right, Shekani, I'll talk to the team. All right, we'll give you access to the portal. All right, try this question.
Done, sir.
All right. Krishna is done. Ronaldo, Kulsum, Shikani.
Yes, sir, almost found it.
Almost all. All right. Kulsum,
I'm doing it.
Shikani. I don't think Shikani is here with us. Rain. Shikani, you can reply on chat if the mic is not working properly. Let's solve this question, Shikani. See, this type of question we have already solved, right? Krishna, how to solve? What do you use here?
So we will first take 2, then we will do 5 into 1 minus 1 into 1.
Can you say that again, Shikani?
5 into 1 minus 1 into 1.
Right. But I'm not asking about the answer here. Just tell me what you use, how to solve this. The first step you write, or the formula you use.
Sir, I used det by adjoint A. That is det into adjoint A inverse.
This one, I guess.
Yes, sir.
All right. Everyone use this. Ronaldo,
Yes, sir.
Kulsum. All right. So we can simplify this further. Just multiply adjoint A inverse both sides. So this will be A equals to determinant A adjoint A inverse. Right. This formula, I guess. And you will get the answer. Just solve this very carefully. All right. No doubts here. Anyone? All right. Let's solve another question based on this only. All right. I'll not give you any hints. Think about how you can solve. All right. Write down the question.
Sir, can you confirm this answer?
So can you solve that question, the one that's done before?
You Shikani, you want me to solve this completely or just the answer?
No, sir, completely.
Completely. All right. That will take a lot of time, but let's solve. See, first let's try to find determinant A is 2, I guess. All right. So A will be 2 times adjoint A inverse. To find adjoint A inverse, we have to find adjoint A determinant. All right. And that would be, anybody can tell me the answer. That would be faster.
4.
4. Shikani, this is clear how to find determinant of a matrix, right? I don't need to solve this, I guess.
Yes, sir.
All right. Now we have to find adjoint of this matrix, right? Let's call this matrix P. So can anyone tell me the cofactors or direct? Shikani, shall I write the matrix directly?
Yes, sir.
All right. So anybody can tell me adjoint of B?
Sir, after transposing.
Right. After transpose the final matrix.
Okay, sir. So 4 minus 2, 2.
All right.
Minus 2, 2 minus 2. 2
All right.
minus 2, 6.
Everybody has this matrix as the answer. Kulsum, Ronaldo, you all got.
Yes, sir.
All right. So A matrix would be determinant A is 2 and divided by 4 times this matrix. Right? This step is clear. So just divide by 2. That means this will be 2 minus 1, 1, and so on. All right. The final answer will be 2 minus 1, 1, minus 1, 1, minus 1. 1 minus 1 3. All right, this will be matrix A. Right, everyone can match this answer. If it
Yes,
is
sir.
wrong, then I'll solve. All right, Shikhani, the steps are clear.
Yes, sir.
All right, Kulsum, the answer is clear.
Yes, sir.
All right, let's solve another question. Don't ask me for hints here. Find the non-singular matrix A if it is given that adjoint of A equals to -1 -2 1 3 0 -3 1 -4 1. All right, if anybody gets any idea how to solve this, please tell me first. All right, just think about how you can solve this question.
That is all.
Yeah, how you can solve this? Any ideas, anyone? You don't have determinant A here, right? The only difference between this question and the previous question is this thing. They don't even want to give you this value. So you can solve this if you have determinant of A. Is that right?
Yes, sir.
So how you can find that? Anyone?
Sir, we can take adjoint and adjoint of A and find the determinant of A from that.
Adjoint of A is already given to you, right?
Yes.
So what is the next step here? Remember that small little formula that was once given to you. Kulsum, any ideas?
No, sir.
No. See, don't forget the formulas or properties. Does anyone remember this formula? Adjoint of A determinant, determinant of adjoint of A formula.
So data power n minus 1.
Right? So you can find determinant of adjoint of A, and this will be equal to determinant A power 2 because the order of this matrix is 3. Right? So using this formula, you can find the value of determinant. And Krishna, only remembering the formula is of no use, right? You should know where
Yes.
to apply that also. All right. And Kulsum, Ronaldo, Shikhani, at least remember the formula, right? Then we'll think about application. All right, everyone.
Yes, sir.
All right, then solve this question.
Done, sir.
All right. Everyone solve this?
Sir, I solved, but I'm not sure with my last answer.
Last answer. All right. Let's match. If your answers don't match, then I'll solve this. Anyone can tell me the answer, final answer?
So my answer is root 3 by 6 into the matrix minus 12.
Minus 12.
Yes, sir. Minus
All
12,
right.
2, 6, 6 minus 2, 0. Minus 12, 6, 6.
All right. Ronaldo, this matches your answer or not? Ronaldo, Shani, Kulsum.
So I got 1 by under root 3, 6, 1 minus 3, 3, 1, 0, 6, 3, 3.
All right. So completely different, I guess. Or you divided this two here, I guess. See,
Sir, I
this
also
we
got the same.
right. See why this? Because this is root 3 by 6. We can write root 3 by 2 times 3, and 2 times 3 is root 3 and root 3. 1 is cancelled. So 1 by root 3. If you multiply this 1 by 2 inside, so this will be minus 6, 1, 3, 3, minus 1, 0, minus 6, 3, 3. Is this the answer? Or not?
Yes, sir.
Right. So the answer matches. So don't confuse by this. All right, Kulsum, this is clear.
Yes, sir.
All right. So, but you all missed one thing. When you are solving this determinant a square, what value did you get here?
Sir, I got 12.
12. Everyone got 12,
Yes, sir.
right? So when you take under root, you should write plus minus 2 root 3. Did anyone write this plus minus?
Yes, sir, I wrote.
You wrote. All right. So you should get 2 matrices, I guess.
Yeah, the next one I got 6. The same thing except there is no minus at the 6 and 1, and there is a minus at 3.
All right. All right. Very good then, right? Because most of students forget this plus minus. All right, Krishna.
Yes, sir, I forgot.
Yeah. And don't miss these things. They'll take 1 marks away from you, which is very bad, right? So this question, I don't think anyone has any doubt, right? Everyone speak,
Yes, sir.
right? So you can see the questions are almost similar, right? Not even similar, same. They just change few things. All right. So that things you need to keep in mind, that you know everything. All right. That confidence should be in you. If you have self-doubt, they will use that against you in the examinations, right? So
Yes, sir. So the other matrix is with the opposite signs, right?
opposite sign, right? This only the sign will change, nothing else. All right. So keep practicing and have some confidence, and just be careful when solving the questions of matrices and determinant, right? The calculations are very tricky, not even tricky, lengthy. So you keep, if you keep making mistakes, that would be very troublesome for you. All right. So this chapter is finished. Anyone any doubt from this chapter?
No, sir.
Ronaldo, Kulsum, Shikani?
No, sir.
No, sir.
All right, then till Friday, you should complete all the assignments. Let's move on with next chapter. which is relations. All right. So first thing I should ask you, anyone remembers what is Cartesian product?
Yes, sir.
Okay, tell me what is this?
So the product of two sets, two or more sets.
Product of two or more sets. All right. Anyone else would like to?
Sir, I have an example like set A comma B and in cross set 1 comma 2, then the answer will be like A comma 1 and B comma 2 like that.
Right.
Comma B comma.
Absolutely right. Yeah, I got the feeling, right? Because whenever you say product, because you know what that means, but the definition is not clear, right? All right. Ronald, you got what he said? Kulsum, Ronaldo,
Yes, sir.
any old memories of class 11? See, what Krishna said is, if you have a set A, which is A comma B, and you have a set B, which is 1 comma 2, then if you find Cartesian product, symbol is this cross, A cross B, then this is the ordered pair, right? The right term is ordered pair. I'll tell you the definition, just understand for now. Ordered pair means this 1 comma 2, the locations, coordinates, right? So ordered pairs make all the ordered pairs possible from this set to this set. So we will write A comma 1, A comma 2, B comma 1, and B comma 2. And this will be a set. All right. So this set of all ordered pairs between two sets is called Cartesian product. Is this clear?
Yes, sir.
All right. Ronaldo, Kulsum, Shikani.
Yes.
Yes, sir.
All right. So if I ask you what is B cross A, Kulsum, can you answer?
1 comma A, 1 comma B, 2 comma A, and 2 comma B.
Absolutely right. All right. So you can see A cross B is not equals to B cross A always, right? So that is another thing to keep in mind. So write down the definition. If A and B are two non-empty sets, then the set of all ordered pairs A comma B, for which A belongs to A and B belongs to B, is called Cartesian product. All right, you can note down the examples also. And is denoted by all right, you can denote this in another way, set builder form, such that A belongs to A and B belongs to B. This is clear, everyone?
Yes.
All right. Noted it down.
Yes, sir.
All right. Ronaldo, Kulsum, Shikani.
Yes, sir.
One little thing here. If A cross B is phi, what is phi?
Empty set.
Empty set, absolute right. So if this is an empty set, that means either A set is phi, null set, or B is phi, right? There is no other case where we'll get an empty set. This is clear,
Yes, sir.
but you can note it down also. Done, everyone?
Done, sir.
All right. So this is Cartesian product. Why did I tell you about this? Because we have to learn about relations. Anyone knows what is the definition of relation?
So
Shikani,
like
your
set A is connected to set B with some equations or something, with some
all right,
relation.
right, with some relation. So in the definition of relation, you can use relation. Is that right? So what is a potato? Potato is a vegetable, right? See, yes, Shikani. Okay, let's see. The relation between set A to set B is a subset of A cross B. You guys remember this,
Yes. Yes.
Yes, sir.
right? This is a subset of A cross B. Now Ronaldo will tell me what is subset. Ronaldo, what is subset?
Sir,
All right, let me give you an example.
sir, like A, if a set A is having some elements and set B is also having the same elements, it is known as subset.
All
Like
right,
some of the elements are same.
some of the elements, right? So if I write 1, 2, 3, 4, 5, and P is 2, 3, 5, 6, is B a subset of A?
No.
No, sir.
No. Why not?
6 is not there in the set A.
Right, 6 is not there. If I remove 6, is B a subset of A?
Yes, sir.
Yes.
Right. Ronaldo, this is clear?
Yes, sir.
All right. So all the elements of one set must be present in another set. All right. Then we'll say one is subset of another. Right. So relation. What is relation? Relation is a subset of A cross B. All right. Now understand this very carefully. Relation is not a very like equation and that, nothing that, like that. Just a subset. If we have a set A comma B, and B 1 comma 2, So A cross B will be A comma 1, A comma 2, B comma 1, B comma 2. All right. So if I write a set C and I write A comma 1 and B comma 2, is C a subset of A cross B?
Yes, sir.
Right? This is a subset of A cross B. Then I can say C is a relation from A to B. Is this thing clear, everyone?
Yes.
Yes.
All right. So any form of subset you create out of A cross B will be a relation from A to B. All right. Now you may think, how will we get A comma 1 and B comma 2? That's not your issue, not your problem. All right. The equation by which these two will be related is their headache, is our headache, the teacher's headache. All right. We have to know that any subset from A cross B is a relation from A to B. Is this thing clear?
Yes.
Yes, sir.
All right. And the equation, why do we write A minus B is equal to 2 and these things? Because we have to find which elements are related to each other. All right. The equations are that only. Which elements are related to which elements of the other set. This is clear. I hope no issues here.
Yes.
All right. Note it down the definition. Done.
Yes, sir.
All right. Another thing, if R is a relation from a non-empty set and a non-empty set B, and if A comma B belongs to R, then we write A is related to B, and this is read as A is related to B. All right. What is this? If we define a relation from A to B and both are non-empty sets, and A comma B belongs to R, that means this is an element of this set, right? This A comma 1 is a part of this relation. So we will write A is related to 1. All right. If you see this thing written, this means A is related to 1. This is clear.
Yes, sir.
All right. Note it down. Write this one also. If A comma B does not belong to R, then we write A is not related to B. All right. You can write this in English also. A is not related to B. All right.
Done, sir.
All right. If A and B are finite sets with m and n elements, can anyone answer this? If A set has m elements in total and B set has n elements, then how many elements will there in A cross B?
2 power m into n.
2 power m into n. And I think Kulsum also answered. What is the answer, Kulsum?
2 raised to m into n.
2 raised to m into n. All right. Ronaldo? See, this is very simple. You didn't listen to the question, I think. How many elements will there in A cross B? This has 2 elements and this has 4 elements. And how many pairs will be in here?
8.
8. Very simple. No need to do 2 to raise to the power 8. Only 8. This is clear, Krishna? And Shikani is absolutely right. Only 8 elements, right? Krishna, Kulsum, this is clear?
Yes, sir.
So if this has m elements, this has n elements, then the total number of ordered pairs possible are mn. All right. Now, if I ask you how many subsets are possible, and that answer would be how much?
2 power m into
2 power n. All right. And this would also be equals to total number of relations possible, right? Because subsets are relations. So total number of subsets would be equals to total number of relations possible. All right. So write this one here. Having mn ordered pairs in A cross B, then total number of relations possible are 2 raised to the power mn. All right. That is the total number of relations or subsets possible. All right. The total number of ordered pairs in A cross B is mn only. This is clear, everyone?
yes.
All right. Note it down.
Done, sir.
All right. Can anyone tell me what is domain of a relation?
So the first elements of an ordered pair in a subset.
Absolutely right. Absolutely. Let R be a relation from set A to set B, then all the first components or coordinates of all the ordered pairs in R is domain of R. All right. How to write this in set builder form? Domain is equals to set of all elements A of belong. All right. So what this means, if there is a relation 1, 2, 2, 3, and 4, 5, then domain would be, Kulsum, what would be the answer? Domain?
1, 2, 4.
1, 2, 4. All right, very simple. Write it down.
Done, sir.
A range of set, range of a relation. This is very easy. Kulsum, can you answer what is range of a relation?
The second components or coordinates of the ordered pair.
Absolutely right. So let R be a relation from A to B. Then the second components of ordered pairs in R is the range of relation. The range would be equals to B such that A comma B belongs to R. All right. For an example, if set A is 2, 3, 4, 5, and B is A comma B comma C comma D, and relation is 2 comma A, 3 comma C, then range would be, Shikani, what would be range? Shikani, what would be range here? A comma C, right? Range is A comma C.
A comma C.
All right. Note it down, everyone.
Done, sir.
All right. Relation to a set on a set. Let A be a non-empty set, then a relation from A to itself or a subset of A cross A is called relation on A. All right, this is very simple. See, we have been studying about relation from set A to set B, right? If I write a relation from set A to set B, then we say subset of A cross B. But if I write relation on set A, all right, if I simply write relation on a set A, this means subset of A cross A. This is clear?
Yes, sir.
The second set becomes the A set itself. All right. Ronaldo, Kulsum, Shikhani, this is clear?
Yes, sir.
Yes.
Right. These are the terminology, right? So that you don't get confused. Write it down.
Done, sir.
All right. Inverse of a relation. Let R be a relation from set A to set B, then the inverse of relation R, denoted by R inverse, is a relation from B to A, defined by R inverse equals to B comma A such that A comma B belongs to R. All right. Just understand this first, then you will write this. All right. See, if I give you a set A, 1, 2, 3, 4, and set B, A, B, C, D. All right. And I write a relation between them, 1, A, 1, B, 2, C, and 2, D. All right. This is a relation. Now, what would be R inverse here?
A comma 1, B comma 1, C comma 2, D comma 1,
D comma 2.
D
C
comma
comma
4.
2. Yeah, C comma 2 and D comma 2. Look at this carefully. 4 is not related here, right? We have 2 comma C. So here we'll have C comma 2. 2 comma D. So D comma 2. Is this clear?
Yes.
So if this relation is from set A to set B, then R inverse is also a relation from set B to set A. All right, this is clear, everyone?
Yes, sir.
Note it down.
Done, sir.
All right. Types of relations. Void or empty relation. All right. Let A be a non-empty set. And R is a relation on A such that no elements of A is related to any elements in A. All right. See, what this means is, if I define a relation in such a way that there are no two elements which relate to each other. All right, for an example, let A be 1, 2, 3, 4. All right, and I define a relation A comma B such that A by B equals to 9. All right, we have a set A 1, 2, 3, 4 having the elements 1, 2, 3, 4. I define a relation on set A such that all the ordered pairs A comma B where A by B is 9. All right, so if you write all the ordered pairs from A cross
Not
A,
possible, sir.
what Shirani?
Sir, it's not possible that A by B is
Right.
equal to 9.
Absolutely right. So what does it mean by not possible? Not possible means we cannot find any two elements where if we divide each other, then we will get 9, right?
Yes.
Right? We cannot say any two elements, right? If you write all the ordered pairs, this will be 1, 1, 1, 2, and so on, right? So no pair will satisfy this equation. So we will say A, B does not belong to R for all A, B belongs to A, right? Not even one element is there which satisfies this relation. So we will say that relation R has no elements. So this will be a R is a empty relation. R is an empty relation or void relation. Is this thing clear, everyone?
Yes, sir.
All right, Ronaldo, Sheghani, Kulsum.
Yes.
Yes, sir.
All right, note it down.
Done, sir.
All right, you wrote down this example also. Right, everything is noted down.
Yes, sir.
All right. Next is universal relation. Just the opposite of empty relation. Let A be a non-empty set and R is a relation on A such that each element of A is related to every element of set A. All right. Then R is a universal relation. What does this mean? All right. This means I define the relation in such a way that all the elements of A are related to each other, right? Not even one pair is left outside. All right. For an example, if A is 1, 2, 3, and 4, I define R in such a way that A minus B modulus is greater than or equals to 0. All right. This, you know what is modulus?
Yes, sir.
Everyone, Aldo, Kulsum, Shikani?
Yes, sir.
All right. So if you write A cross A here, you will have 1 comma 1, 1 comma 2, 1 comma 3, all right, 1 comma 4, and 2 comma 1, and so on till 4 comma 1, 4 comma 2, and 4 comma 3, and 4 comma 4, right? This will be A cross A. Now you take any pair and try to put this in this equation, 2 comma 1. So 2 minus 1 modulus is greater than 0. So 1 is greater than or equals to 0. Yes, this is 2. That means this pair satisfies this equation. That means 2 comma 1 is in this relation R, right, everyone?
Yes, sir.
So can you take any pair and tell me that this pair is not satisfying this equation? Anyone can take any pair.
No, sir. Such pair is not possible.
Not possible, right? So all the elements of A cross A are in the relation R, right? This way, this relation will be called universal relation. Is this clear?
Yes, sir.
Yes, sir.
All right. So all the elements are related to all the elements. You can note it down also. There is one small note also. You can note it down. I'll give you time to write it down, but understand this first. Both empty relation and universal relation are the smallest and the largest relation possible between sets, right? This is the smallest relation possible. This is the largest relation possible. And so these are called the trivial relation also. All right. If you read somewhere as trivial relation, that means they are talking either about empty relation or universal relation. All right. This is clear. So don't be confused.
So it is trivial, right?
Yeah, trivial. Trivial.
Done, sir.
All right. another is identity relation. A relation on a set A will be identity relation if every element A is related to itself only. All right. What does this mean? This means if I give you a set A 1, 2, 3, then all these elements will be related to themselves only. All right. And all the elements must be related to themselves. That means if I define a relation R1, which is 1, 1, 2, 2, and 3, 3. All right. So 1 is related to 1, 2 is related to 2, 3 is related to 3. That means all the elements are related to themselves only. Then we can say R1 is an identity relation. All right. But if I define another relation R2, where 1, 1 and 2, 2 are there, this will not be an identity relation. Not an identity relation. Why? Because 3, 3 is not there. All right. So all the elements must be related to themselves. We cannot leave anyone out. And if I define another relation R3, where I write 1, 1, 2, 2, 3, 3, and 1, 3, even this is not an identity relation. All right. Why? Because 1 is related to 3. Is this clear?
Yes, sir.
All right. Ronaldo, Shikani, Kulsum.
Yes, sir.
All right. Very clear, right? This is very important. You must have seen y equals to x. This equation is sometimes called identity function, because whatever you put in x, the same is reflected backwards.
So I didn't understand this well. I will explain.
All right. You didn't understand this, Shikani? All right. See, if you write any set, all right, then if you define a relation on A, that means you have to take all the ordered pairs from A cross A. Then this relation must have 4, 4, 5, 5, and 6, 6 only. No other elements. And you cannot even leave any of this. All right, then this will be an identity relation. Is this clear now?
Sorry, yes.
You are not audible very clearly, Shikani.
Sorry, yes, I understood that, but what is R1, R2 that I understand?
R1, R2, all right. See. This is 3 relations I defined in A. All right, on A. I told you any subset of A cross A will be a relation. So I wrote 3 relations, R1, R2, and R3. In R1, I wrote 3 elements, 1, 1, 2, 2, 3, 3. In R2, I wrote 1, 1, 2, 2. R3, 1, 1, 2, 2, 3, 3, 1, 3. This is to make you very clear that which will be an identity relation and which will be not. All the elements must be related to themselves. Only that would be an identity relation. If you leave 3, 3, that will not be an identity relation. If you put an extra element, that will also be not an identity relation. Is this clear now?
Yes, sir.
All right. Write it down.
Done, sir.
All right. Now, see, this only word is very important here to understand, right? Identity in identity relation itself only. Now, another relation is reflexive. All right. Reflexive relation. Let R be a relation on set A such that every element of A is related to itself. All right. See, the definition of identity and reflexive is almost same, but I didn't write only here, right? What I wrote only, every element of A is related to itself. All right. For an example, if A is a set 1, 2, 3, 4, and I write relation R 1, 1, 2, 2, 3, 3, 4, 4, and 1, 4. R1. Is R1 an identification?
No, sir.
1 4.
No, right? Because we have 1, 4. But is R1 an reflexive relation?
Yes.
Yes.
So
All right.
reflexive means opposite or what is it?
Shekhani, I'm not able to understand. Reflexive means what?
So what does reflexive mean?
Like reflexive means every element of A must be related to itself. They are not saying that no other element can be there. They are saying 1, 1 must be there, 2, must be there, 3, 3 must be there, 4, 4 must be there. They don't care about, they don't care about 1, 4. All right. So is R1 a reflexive relation? Ronaldo, Kulsum? Kulsum, is R1 a reflexive relation? Ronaldo, what about you? They have left the class, I guess. No, they are there. All right. Krishna?
Yes, it is reflexive.
Yes, this is a reflexive relation because 1, 1, 2, 2, 3, 3, 4, 4 is there. We don't care about 1, 4. All right. If I write R2, 1, 1, 3, 3, 4, 4, and 2, 4. Is this an identity relation?
No, sir.
All right. This is a reflexive relation, right?
Yes.
No, this is not a reflexive relation because 2, 2 is not there. All right.
Sir, 2, 4 is there, right?
right? But we don't care about 2 comma 4. We care about every element of A is related to itself. So every element. So 1 comma 1 must be there, 2 comma 2 must be there, 3 comma 3 must be there, 4 comma 4 must be there. We don't care about 2 comma 4. If it is there, then it is good. If it is not there, then better. But 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 must be there. Is this clear?
Yes. So, sir, identity relation is like subset of reflexive relation, right?
Absolutely right. I'll make you write that. Don't worry. But absolutely right. Identity relation is a subset of reflexive relation. All right. First, note it down. So this is not a reflexive relation. This is a reflexive relation.
Done, sir.
All right. And the thing Krishna said, you can write it down that an identity relation on set A is always a reflexive relation, but a reflexive relation on set A is not necessarily an identity relation. All right. For an example, if there is a set A comma B, then our identity relation A comma A, B comma B. This is an identity relation and reflexive also. But let R2, A comma A, B comma B, and A comma B. This is reflexive, but not identity. Right?
Yes, sir.
Note it down also. Another note is there. The universal relation on a non-empty set is always a reflexive set, a reflexive relation, right? Because in universal relation, all the elements are there, all the ordered pairs. So that is a reflexive relation.
Sir, what is after the universal relation on and
Non-empty set.
okay, sir.
All right, let's solve a question. Three relations R1, R2, and R3 are defined on set A equals to A, B, C as follows. R1 is equals to A comma A, A comma B, A comma C, B comma B, B comma C, C comma A, C comma B, and C comma C. R2 is A comma B, B comma A, B, C, and C comma A. A comma B, B comma C, and C comma A, which are reflexive. All right, send me the answers in the chat. All right, option 1, 2, and 3. Which relations are reflexive, which are not? All right, the question is clear, everyone.
Yes, sir.
All right. Shekani, I didn't get your answer. All of you are absolutely
Can
correct.
you read the second question?
All right.
The relation.
Relation is 1, 1, 2, 2, 3, 3, 1, 2, 2, 3. That is all. Shikani, it is reflexive. That means all are reflexive. 1, 2, and 3. You have to tell me which relation is reflexive, which are not. These are three individual relations. See, Shekani, look at relation 1. All right. We have three elements in set A, B, and C. In relation 1, we have A, A comma A, A comma B, A comma C, B comma B, B comma C, C comma A, C comma B, and C comma C. So in reflexive relation, we only care about the elements being related to themselves. So A comma A must be there, B comma B must be there, and C comma C must be there. So this is a reflexive relation. But in here, we don't have A comma A, B comma B, or C comma C. So this is not a reflexive. Even this is not a reflexive relation. All right. Now look at the question number 2. Krishna is saying this is not a reflexive relation. Krishna, why is that?
So 3, 3 is not there.
This is not 3, 1. This is 3, 3. My handwriting is bad. That is the issue. All right, this is 3, 3.
Okay.
All right, so this is a reflexive relation. All right, Krishna.
Okay, sir.
Shikhani, this is clear also. In the second question, 1, 2, 3. We have 1, 1, 2, 2, 3, 3. So this is a reflexive relation. Let's solve another question. On set. All right, you have to tell me this is a reflexive relation or not.
So it's not reflexive, right?
Not reflexive. All right. I have got 3 answers. Kulsum has not answered. Right. So this is not a reflexive relation, right? Because no one is there. Not even 1, 1, 2, 2, 3, 3. So no one is there. So this is not a reflexive relation. All right. So is this clear, everyone?
Yes, sir.
Yes, sir.
All right. So we did a lot of things in today's class, right? Identity, the difference between identity and reflexive relation. Is that clear?
Yes, sir.
All right. Shekhani, is this an identity relation? This R?
No.
No, right? All right. If I ask you this one, here, R1. Is R1 a identity relation? All right.
R1.
Can you reply on chat?
So
All of you reply on chat if R1 is identity relation or not. All right. Shekhani, see, in identity relation, we only have to have A, B, B, and C, C. All right. If you see anything extra or anything less than that, then not an identity relation. All right. We can only write A, B, B, and C, C.
so it's not identity.
Not identity. Absolutely right. All right. This is clear. All right then. So I hope everything is clear of today's class. No doubts, anyone?
No, sir.
No. All
Yes.
right then. All right. This is all for today's class. In the next class, we are going to learn about few more relations. All right. Please revise this. Don't. If you forget this, then a lot of issue. All right. And you have to complete all the assignments till Friday, right, Ronaldo?
Yes, sir.
All right then. See you in the next class. Take care, guys.
Thank you, sir.
Thank you, sir.
All right.